Hi everyone, welcome back to my videos. I like to solve some algebra problems from the Math Kangaroo competition. So this is problem 23 from the 2017 test for juniors and seniors. So given sequence AN with A1 equals 2017 and AN plus 1 equals AN minus 1 divided by AN, find A 999. So let's try finding a pattern. Let's simplify the recurrence equation as an plus 1 equals 1 minus 1 over an. So a2 equals 1 minus 1 over a1. a3 equals 1 minus 1 over a2. We know a2 equals 1 minus 1 over a1. So if I plug this in and simplify, I get a3 equals 1 divided by 1 minus a1. a4 equals 1 minus 1 over a3 equals 1 minus 1 divided by 1 over 1 minus a1, and if I simplify that, I get a4 is equal to a1, and then we get this the cycling, right? So a5 is equal to 1 minus 1 over a4, and we know a4 equals a1, so then we get this pattern. So for any positive integer n, a1 plus 3n equals a1, a2 plus 3n equals 1 minus 1 over a1, and a3 plus 3n equals 1 divided by 1 minus a1. So what we're going to do, we need to find a 999. So we're going to set each of these equations here equal to 999, and then we have to find which value is going to give an integer. So the first equation, we get n equals 998 divided by 3. That's not an integer, that doesn't work. 2 plus 3n equals 999, n equals 997 divided by 3. That doesn't work either. And then 3 plus 3n equals 999, n equals 332. So this is the one that's going to work. So a999 is equal to a3, which is equal to 1 divided by 1 minus a1, and a1 equals 2017, so a999 equals 1 divided by 1 minus 2017 is equal to minus 1 over 2016. So let's try problem 28 from the 2017 Kangaroo. So we're given absolute value x plus y equals 5, and x plus absolute value of y minus y equals 10. Both hold true. So how big is x plus y? So we're going to consider 4 cases. So first case is x is smaller than 0 and y is smaller than 0. The next case is x is greater than or equal to 0 and y is less than 0. Then x is less than 0 and y is greater than or equal to 0. And then finally, x is greater than or equal to 0 and y is greater than or equal to 0. So for case 1, so absolute value x is going to be negative x. So we get minus x plus y equals 5. And then absolute value of y turns into minus y. So you get x minus y equals 10. Well, if we look at the first equation, the x's cancel and we get y is equal to 5. But that's a contradiction, right? Because y is supposed to be less than 0. So it's not going to be case 1. Let's look at case 2. X is greater than or equal to 0 and y is less than 0. Absolute value of x is equal to x, and absolute value of y is equal to minus y. And then we can substitute, we get x plus y equals 5, and x minus y equals 10. So if we simplify this, we get 2x plus y equals 5, and x minus 2y equals 10. We can multiply the top by 2 to get 4x plus 2y equals 10, and then we can cancel out this 2y minus 2y. We get 5x is equal to 20 and x is equal to 4. And then if I plug x equals 4 back into this equation here, we get 4 minus 2y equals 10, or y is equal to minus 3. So just so we're sure, we know that x is greater than or equal to 0, so x equals 4, so that works, and y is less than 0, and y minus 3 is certainly less than 0, so these two values work. So x plus y equals 4 minus 3, which is equal to 1. Okay, let's try problem 27 from the 2013 Kangaroo. So we add the first n positive integers and we get a three-digit number with all the digits being the same. Find the sum of the digits of n. So this is kind of a tricky problem, but let's look at it. So the sum of the first n positive integers equals n times n plus 1 divided by 2. So that's the formula for an arithmetic sum. So the possibilities we can have, so we need a three-digit number where all the digits are the same. So we can have the sum equal to 111, or the sum is equal to 222, all the way up to the sum is equal to 999. So in general, we can write the sum is equal to k times 111, where k is an integer, right? Such that 1 is less than or equal to k, and k is less than or equal to 9. So we can factorize 111 as 37 times 3. So if we multiply, we cross multiply, we get n squared plus n equals 2k times 111, which is equal to 2 times 3 times 37 times k. So what I'm going to do is we want to make this thing, we want to get close to 37 as possible, and then we'll be able to simplify it that way. So if we choose k is equal to 6, then we get 2 times 3, which is 6, times k is 6, and then we get 36 times 37. So we have n squared plus n minus 36 times 37 is equal to 0. And then I can factor this as n plus 37 times n minus 36 is equal to 0, right? Because you'll have n squared minus 36n plus 37n. So that simplifies to plus 1n, and then minus 36 times 37 equals 0. So we're going to take n equals 36 since n is positive. So the sum of the digits of n equals 36 is 3 plus 6, which is equal to 9. So we use this kind of special property for quadratic equations. So there's a special formula where you can find out the product of the solutions and the sum of the solutions, and then you can kind of work it out from kind of factorize it like this. So that's why I chose 36 and 37, because it would simplify nicely. But this was an interesting problem to solve. So that's all I have for you tonight. So I hope you enjoyed watching my tutorial, and I hope to see you during my next lesson. All right, have a good night. Bye.